Hello, everyone. This is a live stream of Management of Operations, BUSN 6630. And tonight the lecture is on aggregate planning. And before we get started, I was a little bit late trying to get everything organized. Before we get started in the lecture on aggregate planning, and also tonight we're also going to work on the homework 2. Looking at homework 2 and going over homework 2 and going through that. But before we get into that, I want to bring up Canvas. And in Canvas, on the home page, if we come down here to aggregate planning, and there's where we are, I've changed the format around because I've been having emails and people have been asking how to find things. And it's been a little bit confusing, and so I spent a lot of time trying to reorganize things. I hope this reorganization makes things easier to find. So if you click on aggregate planning, and notice what I've done. In aggregate planning, there's only one page here, material. I just say material. You open the material, and everything's going to be on this page then. Notice here I have the aggregate planning, the Word file. This is the lecture notes for this lecture right here. When I get done with this, these are the notes that I'll be using during this lecture. When I get done with this, I will go over, I'll post this video here. So you'll be able to see this video here. So I'm going to go over lecture, the aggregate planning lecture, and also go over homework 2. And also the review of quiz 2 and memo 1. I didn't have a chance to actually put together a presentation of memo 1. I might be able to do that next time. But before memo 2 is submitted, I started putting it together. I haven't completed it yet. But the review is just saying, okay, any questions about quiz 2, and then presenting memo 1. Here's what people did for memo 1, and we'll do that next week because then you're getting prepared for the memo number 2. Which I always find every semester, every time I teach this, the memos coming in, I say there's good news and bad news about the memos. The good news is they're all good in their own way, and they're all different, which I like to see. The bad news is when I go through each one of them and the videos, it's unfortunate that all of my students can't see that with me because it is very, very interesting and informative having the same topic done 20, 30 different ways. I think it's really educational. But if there's any questions on the review here, I will certainly go back and answer questions about the quiz. And the memo 1, I'll do that next week. Now, next week we will review homework 2. So today, with the lecture, at the end of the lecture, we'll be looking at homework 2 and going over homework 2, going through it. Okay. Now, I have a chat room. Let me pop this out. And in this chat room, I want to make sure that it is live and make sure everyone if all intents and purposes, I see everything is in order. Just want to make sure that I'm live, everyone sees this. It's public, and hopefully I have a number of concurrent viewers, and hopefully just pop in and say yes, and we're live and we're good and we're going. Because I want to make sure everyone sees that. Okay. And then also on this page, notice I encourage you to go to, especially with aggregate planning, go to the website, mdharper.com, and go to my operations management. And then when you come down here under aggregate planning, these videos and Excel spreadsheets, these would be very helpful. Now, these videos, as you've probably looked at some of them, these are more presentations. I call them instructional videos. But then this lecture this video is what I'm doing right now. This is recorded, will be posted. This is more of a lecture video. And here I'm just kind of explaining things. And then for this topic down here below. Then I have the office hours, and then right here you have the submission. And this is not live yet. And notice blue is live, black is not live. This will be live, but then I'll post the answers here. But this is for the quiz, this is for the homework, and this is for the memo. So what I decided to do to make it easier to find things is that aggregate planning, the quiz for aggregate planning, the homework for aggregate planning, and the memo for aggregate planning are all right here. You can download the assignments, you can download the homework, download the questions, you can submit them here, and you'll get the answers here. So aggregate planning, it's all on this page. Rather than jumping all around, it gets confusing. And notice, I've graded Memo 1, I've posted the grades, and some of you have noticed, a lot of you who didn't submit a memo, I said, can you resubmit our memo? The reason I want you to submit a memo is because then you get the experience of what I'm getting ready to show next week. If you want to, if you didn't submit the memo, the memos, I'm not strict on the memos like I am with the homework and the quizzes and the exam and the project. That if you submit the memo later, and I said this in a number of comments on a number of people's comment board on their submission, I say submit the memo for full credit, to get credit. And if you want to resubmit the memo, that's fine too. Because I think the memos are much more, they're a learning tool, but it's not like a homework or a quiz where you get the answers. It's like you're developing like a deliverable, you're a takeaway, you're developing something that I want you to take away from this course. And you can redo it and try to get it better and better. Something that you can take away from this course to remember the work that you've done. So that's the kind of thing. Yeah, that's perfectly fine. Right here. I've submitted my memo, but I want to redo it for better grading. Yes, you can do that. And I will regrade them. I want them to be yours. Don't change them to what someone else does. I want them to be your memos. And you'll see here next week when I start looking at the memos, I'll say, here's different people did different things. And here's different versions of this memo. And that's kind of what I want to see. And I want you to find something that suits your personality and what you're comfortable in defending and presenting and supporting. Because when you present anything in business, people are going to ask you about it, and you're going to have to defend it. And so something you're comfortable with, if you submit something someone else does, their thinking is in that, not yours. And sometimes you'll have a hard time and you'll say things wrong. So go ahead and do it. And I think I did put comments. I did put comments on what people missed. If I took points off, I always tell you why. It's in the comments section of what I submit. If I take it off, I'll always say this was missing, or this was wrong, or this was incorrect. I'll always say why. And sometimes I say well done if I think it's really good, and I'll post some of those. But if it's really good, if it's good, sometimes I don't say anything, and that's perfectly fine. Everything was done right. Okay. So those are the memos, and that's these down here. Getting back to the Canvas here, that I'm going to start using this format for the rest of the course, rest of the semester, because I think it's a much better organization of things, and I hope so. Let's see here. Okay, yeah. Now notice on these lecture videos, they are lectures because they're live streams. Okay, but I'm not only giving a lecture here on aggregate planning, I'm also giving a lecture at the end on the homework. So there's a combination of things in these videos. Okay. Okay, are we good to go? I think we're good to go now. Okay, let's bring up the lecture. I'm going to go through aggregate planning and then I'll go through the homework. Homework 2 of linear programming that's due this weekend. And and then if there's any questions after homework 2, back to quiz. If there's any questions on the quiz, I'll answer that. Okay. So let's bring up the lecture notes on aggregate planning. Okay, in aggregate planning, the notes, and these are posted on in Canvas. As we go through here, this gives, again, an introduction, a good introduction and overview of aggregate planning. I go a little bit in depth, and the homework goes a little bit in depth, enough to actually begin using this in industry, in business, but not enough to be an expert. So this is a survey course, but it's certainly enough, lays a foundation that you can build on it. If you do this a year or two, you'll be an expert. Okay, here we go. Aggregate planning. Okay, first of all, let's make this a little bigger. Okay, here we go. Okay, here's the input-output process that we've been using. The input of the resources, and all kinds of resources. The two resources we'll look at primarily in aggregate planning is inventory and labor as capacity. And then the output is going to be a production plan. So the whole output and the whole purpose of aggregate planning is creating a production plan if you're producing products. The process in here in the aggregate planning, here is where we look at things like we'll have different strategies, we'll have different objectives within our plans, we'll have different characteristics that we'll pull out, applications, and so we'll look at a number of things in this aggregate planning. Now, sometimes there's different names for this. Aggregate planning is what I'm using. It's pretty of a general term. It's an older term and general term, looking at everything. Now, production planning is focusing on its output. Sales and operations planning is focusing on connecting the demand or sales with your operations or your resources. So it's look at the connecting of those. And so it's focusing on different parts of aggregate planning. I use the way I define aggregate planning is a general term, is a large term of everything, like an umbrella term. Okay, now a little bit on the concepts of aggregate planning. Well, there are 4 things to look at to get started here. 1, we have demand. 2, we have production. 3, we have inventory. And 3, we have labor. Well, now, labor really is one type of a capacity. Okay, a capacity that results in productivity. You'll have capacity resources, things like equipment, facilities, money, but you'll also have labor and people. So in aggregate planning, we're focusing on labor and inventory to satisfy the demand, but that labor really is part of capacity. Okay, for example, suppose we have, and the 4 things of demand, inventory, labor, and productivity. Those are 4 different things. So let's suppose our labor is constant and our productivity is constant and the demand goes down. What happens to inventory? Well, if our capacity and labor and productivity is constant, demand goes down, inventory goes up. And so aggregate planning will capture those 4 things and start creating strategies. On the other hand, if demand goes down, capacity, labor, and productivity go down. If demand goes up, capacity, labor, and productivity go up, so inventory stays constant. So those are the 4 things that aggregate planning captures, and that's what we'll look at tonight. As it turns out, looking at those 4 things and managing it, you can get some pretty strong and pretty powerful types of plans within an organization. Okay. So let's look at some examples. Let's start with strategies. There are something called two pure strategies, a level capacity strategy and a chase demand. These are referred to as pure strategies. Well, let's illustrate. Let me illustrate. First of all, given. We have given a forecasted demand, 12,000, 28,000, 24,000, 20,000. We bring those down here under demand, and there they are. If we sum that, our annual demand is 84,000. Okay. Now, for these titles up here, down here below, I have the definitions of terms, I have equations, and I have calculations. So I'll be referring to these up here. Okay, here's my demand. Now, if we want a level capacity pure strategy, a description of a level capacity production plan is take the total demand, divide by 4, because there's 4 quarters, and we have 21,000 every quarter. So the sum, the annual production equals annual demand. And notice our production is level. So this is not a definition of level capacity. This is a description of a simple level capacity production plan. What's a definition? Well, it doesn't say level production. It says level capacity. Because what we're focusing in on is labor capacity. And that labor produces productivity. Okay? Well, what's capacity? Well, we have to connect our production with our labor. And the way we do that is called a production standard, where 1 FTE equals 200 items per quarter. Well, the FTE is called a full-time equivalent. Now, a full-time equivalent refers to a full-time equivalent worker. One worker working full-time, in this case, we're looking at a quarter. One worker working full-time for a quarter is 1 FTE. 2 people working half-time for 1 quarter is equivalent to 1 FTE. 4 people working 1 quarter time is 1 FTE. And so a full-time equivalent is a very common metric. And those of you in business probably are used to it. If you've never heard of it, it's extremely common. As a matter of fact, universities use them. You are 1 student credit hour. I am 1 faculty credit hour. And so if you work full time, if I work full time, I'm 1 full time FTE, faculty FTE. If I only work 50%, I'm a 50% FTE. If you are a full time student, you're 1 FTE, 100%. If you're only part-time, then you're not a total 100%. So every organization uses this. The reason they use it is that aggregate planning determines how many FTEs they need. And then with those FTEs, then it goes to human resource management. Well, how many people are we going to use to satisfy those FTEs? And so you might have, well, you're going to have more people than you do FTEs because some people are on vacation, part-time, they have days off, and all kinds of things will happen. Anyway, well, the production standard connects the labor, 1 FTE, with productivity, 200 items produced per quarter. And so this is a standard. So down here, to apply this production standard, then let's suppose in a quarter, suppose our production was 200. How many FTEs do we need? We only need 1. What if our production was 400? How many FTEs do we need? We need only 2. Okay. But if our FTE is 21,000, if our production plan is 21,000 and 1 FTE produces 200 items every quarter, then if we take 21,000, divide by our production standard, we're going to come up with 105 FTEs. So the FTE we need is the production plan divided by the production standard. 21,000 divided by 200 is a capacity of 105 FTEs. So these FTEs define a level capacity aggregate planning strategy. There you go. So now we have our demand, we have our productivity, we have our labor, and the fourth thing is inventory over here. So in inventory, we have a requirement here of beginning and ending the annual inventory of 3,000. So we're going to start BI's beginning inventory. We start the year with 3,000 in the first quarter. We end the year in 3,000 in the fourth quarter. So this 3,000 and this 3,000 are given. But since our demand varies, then the inventory will vary throughout the year. Well, the ending inventory, since we're given 3,000, the ending inventory then, right here, will be the beginning inventory plus our production. The production goes into inventory because it's a make-to-stock operation. The demand takes out of the inventory because it's a make-to-stock. Demand is met out of inventory. Leaves the ending inventory. So the beginning inventory plus production minus demand equals ending inventory. So that equation is given right here. Ending inventory plus beginning inventory plus production minus demand equals ending inventory. So these are referred to as equilibrium equations. So this accounts for all of the labor needed. This accounts for the inventory that is used. And so these are called equilibrium equations. And if these equilibrium equations connect between all year, then a collection of equilibrium equations to make sure that we account for all the labor is called conservation of labor. Now these equilibrium equations for inventory, making sure that they connect, because the ending inventory of the first quarter becomes the beginning inventory of the second quarter. So if all of this is connected, all those equilibrium equations taken together, they're called conservation of labor, conservation of inventory. So we're not going to get into this too much in this course, but where this goes and where you get some more complex and detailed analysis of aggregate planning or production planning or S&OP, sales and operations planning, they're going to have almost every type of analysis has conservation of labor and conservation of inventory, and within that becomes more complicated, more detailed. Anyway, that's level capacity. Now, before we leave this is a strategy. Okay, the next pure strategy is chase demand. Well, chase demand, a good description would be simply take the demand and set the production equal to the demand. So the production equals the demand. So if I divide this by my production standard of 200, I'll get my capacity over here. So notice this capacity, this defines chase demand. So this chase demand goes up and down, and the pattern of increasing and decreasing the FTEs is the pattern contained in the demand. Well, since the production and demand are the same, when we come to inventory, our production and demand are the same, so they cancel out. So the beginning inventory and ending inventory are all going to be equal. So this illustrates a very, very simple level capacity strategy with FTEs, chase demand strategy with FTEs, but it also illustrates one of the most important takeaway concepts of aggregate planning. And the concept is this. Right here in level capacity, and let me highlight this, in level capacity, notice that the FTEs are constant. The demand has variability. It goes up and down, so there's demand variability. That demand variability is seen in the inventory, not the labor. The capacity is level. Therefore, all of the variability will be reflected in the inventory. Or the labor is independent of demand variability. The inventory is dependent on demand variability. Okay? Or all the demand variability will be reflected in the inventory, and the labor capacity the demand variability is not in the capacity at all. So that concept is important because here you have a constant labor force. And so this is focusing on managing labor. It's a constant force. You're not hiring and firing. You're not changing it. The actual labor capacity is level and constant. Now, chase demand, on the other hand, let's look at this. Let me highlight this. Now the situation is demand variability is independent of the inventory, or the inventory is independent of demand variability, but the capacity and labor and the FTEs are dependent on the demand variability. So up here, all of the demand variability will go into the inventory, and chase demand, all the demand variability will go into the labor. And the inventory then is independent of demand variability. And so here, moving from level to chase and chase to level, you can have the demand variability be managed either by your labor or your inventory, and going back and forth, there's reasons why you would go both ways. And we'll get into that in this lecture. Okay, so we've had strategies up here, we've had properties and relationships. What's next? Let's introduce an objective. Now, there's a lot of objectives we can have. I'm going to introduce something called an inventory objective. An inventory objective simply is this. Initially, we had the beginning and ending annual inventory is 3,000. That was given. But now, our beginning annual inventory is 3,000. But let's include an inventory objective of increasing or decreasing the ending annual inventory. So let's look at two cases. First of all, I copied this from above, and notice I start with 3,000 and end with 3,000. But over here on the right, let's introduce an inventory objective where the beginning inventory is 3,000, the ending inventory, let's say, is 3,800. So my inventory objective is increasing the ending inventory for the year by 800. Okay, so if I start with 3,000, I want to end with 3,800. How do I do that? There's different ways of doing it. I'll be talking about 3 different ways to do this, and it's important to know more than one way, because in some applications, one way may be preferred over another way, and some way may be much easier than another way. So let's look at all 3. First of all, one way is to take the total production, add 800 to it, and so my demand is 84,000, my production is 84,800, and divide that by 4, and that gives me my quarterly production. Divide that by my production standard of 200, and I have my FTEs. That's one way. A second way is take this 800, since it's quarterly, divide it by 4, so it's 200, 200, 200, 200, and add 200 to every quarter. So 21,000 would be 21,200 every quarter. Well, if I add that up, then the annual is going to be 84,800. Divide that by my production standard, and I get my FTEs. So sometimes that's the easiest way to do it. A third way is if I take this 800, I divide this by my production standard of 200 items per quarter. Now this is a quarter. So 800 over 200 is 4. So this is referred to as 4 quarterly FTEs. 1 FTE working full-time for 1 quarter. That's what that means. So I need 4 of those quarterly FTEs. So I can take that 4, and since I'm increasing my inventory, I'm going to increase my capacity by 4 quarterly FTEs. Well, I take that and spread it evenly throughout the year. I'll add 1 FTE every quarter, so the 105, 105, 105, 105 becomes 106. Well, some people say, why do you spread it evenly? Why don't you put all the 800 in the first quarter? Or put all the 4 in the first quarter? Why don't you do that and make that 109? Well, you can. Some people do. There's nothing wrong with that. It can be done, and it is done. But if you do that, then this plan no longer is level capacity. The capacity is no longer level. It's something called hybrid or mixed. It's something, it's no longer level. Something different. So if we want level capacity, then the only way is take that 800 and the 4 and spread it evenly either over the production plan or over the capacity. Then we come to the inventory. We start with 3,000 plus production minus demand equals, but notice our production now is 200 more. So instead of 12,000, it's 12,200. Instead of 5,000, since I have 202 quarters here, it's 5,400. Instead of 2,000, it's 2,600. And then finally 3,800, and there's my goal. Now, why would anyone want to do this? Well, the application is pretty, once you start thinking about it, it's pretty practical and it's pretty obvious, is that when you anticipate growth, when you anticipate a huge step function in demand, when you anticipate something in your demand is going to be big next year, we have a convention coming to town. We have the Olympics coming every 4 years, and it's coming to our town. Oh no, we're going to have a lot of demand, a lot of people coming in. So somehow when you're expecting this, then start building up now your inventory to address that demand when it hits you immediately. And if you don't do that, you're going to run out. And if you have demand, but you don't have inventory to meet that demand, that's called stock out. Stock out, you lose money, you lose customers, and sometimes if it's too much, you'll lose brand, you'll lose image, and you lose a lot. People don't like stock out. And so what they will do is build up their inventory, and the extra cost of inventory is small compared to the cost of stock out. And that's why people carry more inventory. Okay, so there's a very good reason for this. Okay, now let's look at chase demand. There's some good lessons here. Now here, I know on level capacity, this could have been increase or decrease, either one is right. Same with chase demand. I picked decrease though. I picked decrease here, and let's underline this. I picked decrease as an illustration. Decrease by 100. So now, I think the easiest way is take this 800 divided by 4 and subtract 200 from every quarter. So instead of 12,000, it's 11,800. Instead of 28,000, it's 27,800. Instead of 24, 23,800 and 19,800. That's probably the easiest way, or just as easy is I'll take the 4 quarterly FTEs. I'm decreasing it now, so I'm spreading it and subtracting 1 FTE every quarter. So 50 goes to 60, goes to 59, 140 goes to 139, and 100 goes to 99, etc. Okay, and then I have my inventory. My inventory plus production minus demand. Well, since I'm subtracting 200, then my ending inventory here was 3,000. Now it's 200 less, 2,800. The second quarter, 3,000 goes to 400 less, 2,600. 600 less, 2,400. And finally, 800 less, 2,200. And that's my goal. That's my objective. Now, why would anyone want to do this? Well, here, if these FTEs are very, very good, if your worker, if your labor, if your production process is extremely efficient, and they can meet that demand, whatever it's given, then you really need that inventory less and less. Why should you have a lot of inventory if you're meeting your demand with your production? Okay, well, you need some inventory, but do you need that much? Good point. So we can reduce the inventory. Well, if you reduce our inventory, which one controls inventory more? Well, all of the demand variability for chase demand is in the labor. Therefore, we can control this inventory and increase it and decrease it because we have control of it. Well, theoretically, if I can go down to 2,200, I can go lower and lower and lower, and theoretically, I could go to 0. So if this, let me just delete this for a second. If my inventory goes to 0, theoretically I'll say, then what kind of operation do we have now? We no longer have a make-to-stock operation. Now we have a make-to-order operation. So in this case, we'll probably never go to 0, but we can reduce our inventory to very small amounts, because inventory is costly to carry if you don't need it. But you do need some. So if people want to move from, they have waste in their inventory, and they want to move to a lean operation and reduce their inventory, but they want their production to match up with their, to chase their demand, they'll move to a chase demand strategy, lower their inventory, and all of a sudden your production becomes efficient, your inventory becomes less, and you only need just what you need, and that's referred to as lean operations. And if you do this quite well, and your production of your FTEs produces to meet your demand, that's called just in time. As it gets closer and closer to using less and less inventories, make to order inventory strategy, but also just in time production strategy. So there's all those terms, and you see right here where it happens. Here is the room where it happens and the table where they talk about it. This is the room where it happens. Okay. Now, before I leave this, let me enlarge this, and let me give a story, talk about a scenario that is, to me, I think is very appropriate at this time. Let me get this centered here. That's a little too big. Oh, no, it's not. Move this over. There we go. Okay. Okay, scenario. And here's an application, a very good application. Let's suppose that you're a consultant. You get a call from this company. They say, hey, I need help. Okay, what's your problem? And the caller on the other side says, I have an inventory problem. You have an inventory problem? Yes, we have a big inventory problem. What's wrong? Well, we keep running out of inventory. But then we have to turn around and build up our inventory. We try to build it up, then we run out. Then we build up, then we run out. So we got an inventory problem. Could you come and help us? We go, okay, I'll come and help. So you come to the shop and you say, tell me about your shop. Tell me what's going on. And so they say, tell me about your operations. Okay, well, our FTEs here, they are great. They're the best people in the industry. When we give them a production plan here, they meet that production plan so efficiently that we've won awards as far as well as we've done things. I have the best people in the industry. They're so sharp that there's little to no waste, and they make that production plan exactly every single quarter. Oh, okay, well that's good. And then they say, but that's not our problem. Our problem is an inventory problem. We keep running out. I told you inventory, not production. Okay, well tell me a little bit more about what you do. Over here, how do you forecast your demand? And they say, what? How do we do what? How do you forecast? Well, we don't do that. What do you mean you don't do that? We don't use forecasting. Well, how do you know what to produce? Oh, that. Oh, well, that's easy. Whatever demand we have within a quarter, that becomes the production in the next quarter. Oh, so it's like a moving average with a window of 1. It's called the naive forecast. A lot of companies do that. So in the first quarter, if your demand is 12,000, that becomes your production in the second quarter. And they say, yeah, that's how we do things. That's how we've always done it. So in the second quarter, if you're producing 12,000 and your demand is 28,000, then the second quarter of every year, you're going to run out of inventory. Yeah, how did you know that? How did you know? I didn't tell you it was second quarter. How did you know it was the second quarter we ran out every time? And then if 28,000 is a demand, that's your production in the third quarter. And if your demand is 24, but you're producing 28, then you can start building up inventory and build it up in the third and fourth quarter. Yeah, and actually in the first quarter. Yeah, how did you know that? Yes, we build it up. How did you know that? Do you work here? And says, nope, I see what's happening here. And they said, let me tell you. So he says, but we have an inventory problem. Yes, the inventory is where you see the problem. That's not the source of the problem. I think to solve your inventory problem, you need to have a forecasting department to get good forecast, because your production people are excellent. Yes, they are. Okay, I agree with you. But your forecasting is non-existent, and that will create problems in your inventory. And you don't solve inventory by increasing and decreasing inventory. Back in business, when I was working in business, we call that putting out fires. Have you ever heard that term? You put out a fire, put out a fire, put out a fire. You always have fires to put out. Why? Because you're trying to solve the problem over here, and that's not where the solution is. The solution is over here. It says you need a forecasting department to forecast the demand, and if you're forecasted, give those forecasts to your people to make that, and you'll never go out of inventory. As a matter of fact, you can reduce your inventory to very small amounts, and you'll never run out with forecasting. Wait a minute, that doesn't sound right. In our industry, when we run out of inventory, we make more inventory. We just need more inventory. I says, that's wasteful. Whoops, that's wasteful, and that's an example of lack of operations people not doing operations. You don't understand. This is not hard, but it's not obvious. A lot of people don't do it. But you're going to need some inventory. They say, oh, okay, trust me. You can lower your inventory and not run out. That does not make sense to me. Yes, it doesn't make sense the way you've been operating. But if you operate everything together in concert, in a synergy, then it does make sense. When you actually look at the operations. Would an ERP system be what businesses use to do this automatically? No, good point. An ERP system does not necessarily do this. Within an ERP system, that's a huge system. Within an ERP system, all that is transactional. This is strategic. In other words, ERP just communicates upstream and downstream, upstream and downstream. This is analyzing how much do we produce? How much are we going to produce? Remember, the whole point here is getting this production plan. Well, if you have a demand over here, if you have a chase demand strategy, and how much inventory do you carry, you don't go to zero. But we know that this demand over here, there's going to be variability in demand. We see the variability. I popped it. We see this demand has variability, but when we estimate that value has a variability to it. Well, it's not exactly 12,000. The demand has a little bit of a variability every quarter. And depending on the level of uncertainty here, that's how much inventory you carry so you don't have stock out. So the amount of inventory here should be reflective of how much uncertainty you have in your forecasts. So this is like seasonal. That's explained variability. The unexplained variability, the random component, is a function of how much inventory you should carry. So the random component in your demand will determine how much inventory you should carry. Well, how much should you carry? When we get into inventory theory, we'll have probabilities associated to that. What's the probability of running out? A 10% chance of running out. Well, you need this much inventory then. And so we'll look at that, and we'll see that when we look at inventory. Interesting, isn't it? So it's not hard. Once you get it, you'll do it 2 or 3 times, a couple of months, and you're an expert. It's not hard, but it's not obvious. You'll never figure this out. No, I wouldn't say never, but you don't figure this out. People don't figure it out unless they see it or someone shows them. Okay. And so this determines what's going to be done. ERP system connects. Once you know what you're doing, it's actually transactional upstream and downstream. And we'll look at ERP systems when we do MRP. Okay, so there is the idea behind an advantage or how this is used. Okay, and so you notice how you can have a whole course just on aggregate planning, and actually just this part. There's a lot more than just this, but you can see this alone, a skill of how to do this, and it's not hard. Having a template, having Excel spreadsheets is all you need, and putting all that data in there to see what you need to do, get your forecasted demand, see what your production variability is, and then you can determine how much inventory you need, and you can go into lean operations, move to JIT, and you, with just an Excel spreadsheet, can make your operations extremely efficient. Okay. Okay, let's move on. It's easy to get excited over this stuff, isn't it? Anyway, yes, it is. Okay, good. Well, we've looked at the objective now. Now, the next thing, let's look at a cost analysis. Now, remember, we're looking at labor and inventory, so let's do a cost analysis of labor and inventory. Okay, well, first of all, we need to define unit cost. We need to define unit cost and total cost for inventory, hiring, and firing. So the labor is going to be hiring and firing, and our inventory is going to be carrying cost. Well, C sub C, big C is cost. Let me make this larger. Big C is cost, little c is carrying cost. That's a unit carrying cost, and that's how much it costs to carry one item for 1 year. And the way you calculate that, and you'll see that in the homework, you know, there's all easy ways to do it. There's more direct ways to do it. How you estimate these unit costs, there's all different techniques of doing it. But we're not doing that in this development. We're saying we just have the number. So $9 per item per year. But if that's true, it can be prorated over an item. 2 items would be $18 a year. 3 items would be $27. But if we go half a year, 1 item would be $4.50 for half a year. Okay. Then the labor is hiring cost and firing cost. Now I'm using the terms hiring and firing. Now this is talking about FTEs. It's not really referring to hiring people and firing people. We don't do that all over the place. Hiring and firing is increasing or decreasing FTEs. Now you can hire FTEs or increase FTEs by just going from half-time to 3/4 time for 1/3 of your workforce. You can fire FTEs by going from 100% FTE to maybe 50% FTE for 20% of your workforce. So increasing and decreasing is increasing and decreasing your capacity of your FTEs. That's all the hiring and firing means. I use hiring and firing because it's very descriptive. So it's more of a descriptive terms and not literal. Okay, whether the unit for each FTE, it costs 150 to increase and 250 to decrease. The reason these are different is because increasing and decreasing are 2 different operations. It's not the same in reverse. It takes different things that you do. I can extend this to a year or to some planning horizon. The total carrying cost is the average annual inventory times a unit cost of carrying each individual inventory item. The total hiring cost is the annual number of hires per year times 150. The firing cost is annual fires per year times 250. And if I add all 3 of these together, I get something which I call the total cost. Hiring and firing and carrying cost. Okay, and there you go. Okay, now let's do a cost analysis. Let's start with level capacity. Let me increase this, make it better you can see it a little easier. Okay, let's start with level capacity. So I copy these units up here. I copy them here: labor cost, hiring and firing, carrying cost, and the annual cost, and production standard. Okay, now this right here, this table right here, I copied from the very first page. We've already done this. And now let me move up here and let me show you what I mean. So this very first page at the very beginning, this table right here, I copied that. I copied that down here. And there it is. Well, I call this a solution table because remember I said the four things of demand, productivity, labor, capacity, and inventory? Well, those four are given right here. So these four are sufficient in defining the solution to level capacity. So this pretty much defines level capacity in a very simple, in the simplest way possible. Okay, next. We want to analyze this solution. Now, I'm going to do a cost analysis. Let's reduce down a little bit. I'm going to do a cost analysis. So, and I have an analysis table here. Now, I could have said cost. I could have said that. I didn't because I want to emphasize analysis. Because this is a cost analysis. It could be a cost analysis, inventory analysis. It could be a risk analysis. It could be a sustainability analysis. It could be all kinds of analyses. Okay, this is cost. So here's how we do it. First, we take our labor down here. Here's our FTEs. Well, those FTEs are constant, so there's no hiring and no firing. And so over the year, we're hiring and firing nobody, so the cost is zero. That's easy. My inventory, though, I bring that down, and I do have inventory. Well, like I did up here, I want my average annual inventory times my unit cost. So I average all 8 numbers from the beginning to be safe. I average all 8 numbers to get an average of 5,500. Each one of those items throughout the year cost me $9 to carry, so $49.5 becomes my carrying cost. I add all 3 of those together as my total cost. So this is a really simple introduction to cost analysis. But notice I have all of these numbers over here on the right I haven't even mentioned yet. Because it's more computation, it's more data, and it's more information. Let me show you what it is. This average inventory is the average inventory per quarter. 3,000 plus 12,000 divided by 2 is 7,500. The average of 12,000 and 5,000 is 8,500. 3,500, 2,500. But then my carrying cost is $9 per item per year. Well, over a quarter, my carrying cost per quarter, if I divide that by 4, I get $225 a quarter. So my average inventory per quarter times my unit carrying cost per quarter gives me my total carrying cost per quarter. So this represents my total carrying cost for each of the quarters. So the annual is $49.5, which is going to be the same as this. So it's the same number, but I do it by it's the same arithmetic, I just do it in different order, and this gives me more information. Well, this information is valuable because this shows you the cash flow in your warehouse, because your inventory is your warehouse. This is the cash flow required throughout your warehouse. So this can be used for budgeting. For example, let's suppose that your budget comes down and you see it, and they take $49.5 is the estimated annual cost. They round that up to $50,000 and divide that by 4. And so your budget is $12,500, $12,500, $12,500, $12,500. Well, you take that budget, you look at your actual cash flow that you've estimated, you go, whoa, wait a minute. This first half of the year, every single quarter, I'm going to spend more than $12,500. I'll spend a lot more. Well, 12,500 is what, 25,000, half 50. But I'm going to need 16,875 and 19,125. See, this is $36,000. Instead of 25, I need 36,000. And what if you don't get it? Well, you're going to spend this. You're going to be over budget. So halfway through in 6 months, they do a review, an audit, and they say, oh, the warehouse, this material manager over here, you were budgeted $25,000, but you spent $36,000. So obviously, And actually, the first quarter was 16,875. The second was 19,125. Well, I see a trend going here. So the third and fourth quarter, we're going to budget you even more than 25,000. We'll budget you 30,000. Says, no, I need less. I'm going to come down. Says, you've demonstrated an increase of cash flow. And says, no, I'm predicting a decrease in cash flow. Well, this is not hard, but so many people who are not in operations will not see this, and they will not even understand it. They say, well, no, this is the budget you should have, and you might be over and under, but not much, very small percentages. But if it's a level budget, 12.5, 12.5, 12.5, 12.5, you're going to be over and under a significant amount. And here's an example, okay, of that. So here's how can that happen? Well, people have their silos and they don't communicate, or people in operations are there, but they don't understand operations. And that does happen. People are very good at this over here. They move them operations, think they can do it. Well, they can make the decisions, but those decisions are not necessarily well thought out. Let's go to chase demand. This is a little bit different. So now when I bring down my FT, and again, here's my solution table. Then I go to my analysis table down here. When I bring my FTEs down here, now notice that my FTEs do change. Let's make this larger. They do change. So follow my logic. In quarter one, I have 60 FTEs. At the end of that quarter, I have 60 FTEs on board. At the beginning of the second quarter, I need 140. So between the first quarter and second quarter, I need to increase my FTEs by 80. So my hire is 80 at the beginning of the second quarter to bring that 60 up to 140. So I'm going to hire 80 at the beginning of quarter two. Quarter two to quarter three, I'm going down, so I fire 20. 3 to 4, I fire 20. Now at the end of quarter four, I have 100 FTEs on board. After quarter four, the next quarter is going to be the first quarter, which is 60. So this 100 has to go down to 60. So I'm going to fire 40. So it's a wraparound, and that's called a steady state analysis. It's steady state because every year we're planning into the future. It might change, but our planning is assuming that everything stays the same. I mean, we're not operating 1 year and quitting. Every year we'll be going year after year after year after year. And so you want a smooth transition from the fourth quarter into the first quarter. Okay. So now when I add this up, hire and fire here, I have 80 and 80. And if my beginning inventory is 3,000, my ending inventory is 3,000, then, and if my annual production equals my annual demand, then these two numbers should be the same. Times my unit cost gives my hiring and firing cost. Now when I bring my inventory down, well, that's easy. Everything's 3,000. Everything's 3,000. So everything's constant. Everything's constant over here. Okay? And 27,000 here, 27,000 here. No problem. And then I add all three together, and there's my 59,000. Okay. Again, we see what our cash flow is. Now this time, our cash flow or a budget will be constant. Which brings up a very good point. If you have a budget for your warehouse, for material management, that's constant, that's the same every quarter, then that is assuming a pure chase demand strategy. But if you have a pure level capacity strategy, call it level capacity, LC, and you have a constant budget, then the decision you made down here in your budget assumes chase demand. When you don't have chase demand, you have level capacity. So what this illustrates is another very important part in operations. Quite often, people will make decisions down here. And this decision down here says, this sounds good, let's just do it. Well, that decision, without them knowing it, presupposes that another decision was made up here. And if it wasn't, then you have a disjoint. And that disjoint causes waste and cost, and it begins to balloon. Okay, that's referred to as disjoint. You have a disjoint strategy in your operations. How can that happen? Well, people make decisions down here because they think, oh, let's just do this. Well, wait a minute, let's think this through. What type of cause and effect do we have? What assumptions do we think that we made earlier on? What strategies do we have? What's our cost structure, et cetera, et cetera. And so sometimes decisions down here do not match up with strategies that are made at a higher level. So they have to coordinate. And that's why you need operations not only at the bottom level, at the line level, but also at the planning and strategy level. They have to understand this as well, because they will create policies. Okay. Scenario, question here before we leave this. What if our carrying costs, let's look at our costs. What if our carrying costs got large? All of a sudden it went from $9 to $19, got more expensive. It went to $90 to $900, $9,000. Whoa. For some reason, our inventory just got really expensive. Well, which one of these strategies would that drive a company toward? Level capacity or chase demand? Well, initially, the average inventory here is 5,500. So it's going to cost, if this is 9,000, it's going to cost you a lot more than 9,000 times 3,000. That's a good point. So it'll move to chase demand for that reason. But a better reason, remember, chase demand, you have control over your inventory. You have maximum control over your inventory for a pure chase demand, which means as my unit cost goes up, I can move to chase demand and then lower my inventory. So if my cost goes up, I'll just go to chase demand and lower my inventory. And the net change in my cost here, it stays the same. It doesn't change. And so as my cost keeps going up, I can go move to chase demand, keep reducing my inventory. So you can absorb variability in cost structures with just managing your strategies to a certain extent. And when it gets too much, you can't. All of a sudden, you run out of inventory. But you can absorb that cost with good management if you have someone in operations who knows what they're doing, and they have control, and they're empowered to do that. And you can shift things around to where they can do that. And the cost structure external to the organization is transparent to the cost in the organization. So even though the cost is more, the total cost doesn't change. Interesting. And so there's so much you can do with this strategy within a company. Okay. Well, notice I mentioned going back and forth between level and chase, I keep mentioning that. Well, the level and chase are pure plans. They're called pure plans, like two ends of a spectrum. Well, there are plans that are between these two. That's not level, that's not chase, that's some other plan. I call that a mixed strategy. And the textbook calls it a hybrid, which is a good enough name, a hybrid strategy. That's fine. I like a mixed strategy because it's a little level, little chase. It could be a mix of anything. Okay? And so to illustrate a mixed strategy, I take the same demand that we had, the same costs up here, but this time I assume an arbitrary mixed production plan. And I want to emphasize the term arbitrary. This production plan was not calculated. It was arbitrarily selected, chosen. But it was selected to satisfy three conditions. The first condition was, obviously, the plan could not be a level plan, it could not be a chase plan, because if it was, then it wouldn't be mixed. So that's the first condition. That's easy. The second condition that I put on this particular plan is I wanted the total production equal to total demand. I want those two numbers to be equal. And the third condition was I'm going to pick this production plan such that there is no negative inventory levels. There can be zero, that's fine, but no negative inventory levels. Now, having said that, I'm using that as a requirement for this development because I want to emphasize aggregate planning. There are negative inventory levels, so that does happen. But unfortunately, a lot of textbooks would say if you have negative inventory, that's back order. And that's not necessarily true. Negative inventory is referred to as stock out. When you have demand on your system, but you don't have inventory to satisfy that demand, that's called stock out. But you can handle stock out in more than one way. Back order is just one way. There's other ways. And we'll talk about that a little bit in inventory when we get into inventory. Okay, but for this mixed plan, no negative inventory, the total production equals the total demand, and that production plan cannot be level or chase. So, for any problem here, there's only one level plan for any problem that's given. One level plan, one chase plan, but there's a lot of mixed plans in the middle. Because this could be, instead of 19, 19, 20, 23, this could be 18, 20, 22, 24, it could, or 24, 22, or something like that. So I can make I can make a lot of different production plans that are mixed. But there's only one level and one chase, but there's a lot of mixed plans. But then what I'm doing here is I left the analysis table. I'm not going to go over this again. I'll leave this as an exercise for you to make sure that you can go through and see how all this stuff works. But the reason for this third plan is a third table. We have a solution table that defines a strategy, an analysis table, one of many analyses. And now we're getting to hierarchy of planning, a planning hierarchy. And the final stage coming back together is called a comparison table. Well, here I have the level strategy, chase strategy, and mix strategy in a comparison table. Here's where planning happens. Here's where you actually plan. Okay? And so let me illustrate a little bit on how this is used, and also the power of aggregate planning a little bit more too. Well, notice I don't have everything here. All I have is a production plan and labor and total cost. I don't have inventory. There's a lot. I don't have my demand. So there's a lot in here I don't have. So this comparison table is on labor and total cost. Well, this is one planning meeting. The next planning meeting, we may focus on inventory. Okay, so every planning meeting, every comparison table will look at different parts of the problem. But there's a lot of information in this comparison table. Tell you what, let's do. Let's bring this down. And let's take some rounded figures here. Let's round that 49.5 up to 50K. Okay. Let's round this to 60K, just to have round numbers. And round this up to 40K. Okay. Just for illustrative purposes. Okay. So, remember, this is the same operation, same people, same everything. You're just running it differently. You're just managing it differently. Well, level is 50,000. Chase is 60,000. This arbitrary mixed was 40,000. But notice, here's why people want to invest in aggregate planning. If you have a chase demand, it's a $60,000 cost to run this thing. If you go to this arbitrary mixed, then all of a sudden the cost is $40,000. So you're decreasing this by $20,000. Well, $20,000 in this simple example is 1/3 of the total cost. So you're decreasing your total cost by 1/3. That is significant. A lot of organizations, let me answer some of these questions. Well, let me say this. A lot of organizations would spend thousands of dollars to decrease that cost by 3 or 4 or 5% because it's ongoing, and they'll make it back. But if you can just change, not spend money, but change how you operate things, now all of a sudden you're reducing cost by over 30%. That's significant, and that's why people do it. One more thing, and then I'll go to the chat room. Level. Remember, level has control over labor. Oops. Chase has control over inventory. And mixed, this is looking at cost, has a lower cost. Okay, it doesn't minimize cost, but it looks at lower cost. So if you want from this cost, this mixed plan, if you want to have maximum control over your inventory, that'll cost you $20,000 premium. If you want to have control over your labor from this cost here, it's going to cost you a $10,000 premium to control your labor better. So this does not have the same amount of control. This mixed plan here does not have the same amount of control over inventory as the Chase plan does. But it'll cost you $20,000 to have that control. This doesn't have the same amount of control over labor, but it'll cost you $10,000 to have that control. And so this premium is a way to analyze management decisions. Okay, before I go on, let's come here. Where would be the hiring and firing costs for each Q reflected in the TCC? What would cause CC to increase? Oh, the carrying cost to increase. Your almost anything, fuel costs, taxes, insulation, labor costs, minimum wage goes up. What monies do you spend on handling your inventory? Okay, you have warehouses, you have rent, you have lease, you have people, you have salaries, you have refrigeration or heating in the winter, refrigeration in the summer. So it goes on and scrap, and it goes on and on. So there's a lot of costs in running a warehouse. Okay, hopefully that answers it. Now, as far as Raphael, as far as where would the hiring and firing cost for each Q, I'm assuming you mean the quarter. This is aggregate. I didn't do the cost for hiring and firing every quarter. You could, if you wanted to, and maybe you should. So in other words, in your analysis table, maybe you'll do the cost of hiring and firing. It's a very good point, and some people would. And so you have, this is your cash flow for your inventory. You can have another cash flow for your labor. Okay, good point. Okay, but this right here is this is just an arbitrary production plan, which begs the question, which leads to the question, begs the question, could we calculate, well, this was arbitrarily chosen, can we calculate four numbers to actually minimize the cost? And the answer is yes. What technique would we use to find a production plan that minimized the total cost? Linear programming. So linear programming then is a technique, a preferred technique in aggregate planning. It's used a lot. So aggregate planning for LP can determine a minimum cost optimal plan as far as cost is the objective. Well, here, to develop this, I'm just going to show you here, but when I talk about the homework, I'll actually go and actually work the problem. I'm not going to work it today. I'll work it when I get to the homework. The homework for this. Okay. Here is the this right here. Notice this is the arbitrary mixed plan. So what I will do is take this plan, I come down here and zero everything out, and I'll set it up for linear programming. Okay, first of all, I have my demand, that's given. And so my production plan, I'll put zeros in there. Hiring and firing, put zeros in there. Now these right here, let me come up here. Design, shade, shade it. Okay, there I've shaded it. It's not very much, is it? Let me shade it a little bit darker so you can see it. So I've shaded this because these are going to be my decision variables. down here, these are my decision variables. Okay, then I need to connect, then over here, here's my total cost down here. Let me shade that in. So here's my objective function. I want to minimize my total cost by changing these cells. So here's my decision variables, and notice there's 12 of them, 12 dimensions. I'm going to change these variables. That's my decision variables. Here's my objective function. I'm going to minimize that total cost of my objective function. But somehow I have to connect these variables to my total cost. And that's what this is for in here and down here. Okay? So first of all, the FTEs. So the FTEs right here is saying, okay, I want my production plan divided by my production standard, and that'll give me my FTEs. But then let's look at quarter 2 here. Quarter 2. Let's bring this down a little bit. Okay, so for quarter, let's see here. I think this is not going to do it. Yeah. That's what I thought. Oh well. I do want to do this. Let's see here. Oh, I know. Okay. Let me just increase this, and then let me alter this so I can do my magic here for you. There we go. Now let's bring over and let's tighten this up a little bit if it can be tightened. Okay, now what we're going to be doing here is taking this, okay, and then moving this to the right. Here we go. Okay, let's look at quarter 2, the second quarter. So in the second quarter, I'm going to say, okay, my FTE in quarter 2 will equal my FTE in quarter 1 plus what I hire in quarter 2 or minus what I fire in quarter 2. In other words, whatever FTE I have right here, that's my FTE2, that's going to equal my FTE1 plus what I'm hiring in 2 minus what I'm firing. So only one of these have to be 0. I'm not going to hire and fire at the same time. Okay, for example, suppose this was 1 and this right here was 2. Then I'm going to hire 1. So 1 plus 1 is 2. And what if this was 2 and this was 1? So I'm going to fire 1 because 2 minus 1 is 1. Okay, so this right here represents the FTE equation where you're connecting one quarter, one interval, one time interval with another one. But what I'm going to do, though, is I'm going to take the this right here, and I'm going to take and move the FTE2 to the other side. Move this to the other side. And if I do, it's going to be a minus sign. Okay. But notice I have FTE1 in minus 1 plus hire minus fire minus FTE2. But if I do that, this is going to equal 0. So I just rearrange it with algebra. So this right here connects my FTE in quarter 1 and quarter 2. So this is going to be the equation in that cell right there where I have the left-hand side, where the left-hand side will be constrained to be 0. And that just makes, and if I make that 0, that means quarter 1 and quarter 2 are connected. I'll do the same thing between 2 and 3, same thing between 3 and 4, and same thing between 4 and 1. So this left-hand side here really represents my left-hand side, this equation. That represents my equilibrium equations and conservation of labor. And then over here, my inventory is like I did before. This ending inventory is beginning inventory plus my production minus my demand. And then the inventory, the beginning of inventory quarter 2 equals the ending inventory of quarter 1. Then I copy both of those all the way down. So that's really that's going to be my setup. And as I say, I'll show when I start working problems, this is how you do it. And the video will show you this too. I have a video that shows you how to do this. Then I'll show you, there we go, and work through it when I work the homework. Okay, now my constraint set is I want all of these to be 0. That's this first constraint. I want my ending inventory to be greater than 0. I can't have negative inventory. And then what I did here, I don't have to do this, but I will. I want my ending inventory here. I want to set that equal to 3,000 because that's a requirement. The reason I do that is because often we want an inventory objective. Well, if I have an inventory objective, I don't want to reformulate this thing. I'm just going to change this number. Change the number and run it again. And you'll see it's a lot more efficient that way. And then when I set this thing, I run it, and I come up with this solution. So you can try this on your own and see if you can get this solution. If not, then the next time we're together, when I start working the homework, the quiz and the homework, I will work through this with you when I start working problems. Okay, now, so now I'm taking this optimal plan, which is the solution table. Again, I'm going through my analysis table and getting these costs. Okay, and at this point I can say, you know, I can go back and modify this LP, and I can say I want all my hire and fire. I'm going to force all these. A constraint in my LP, in my solver, I want to force all them to be 0. And if I do, what's that going to give me? Level capacity. Whoops, I'll do that up here. Make all those the same. Make all the hire and fire 0. I get level capacity. But what if I force the production plan to equal the demand up here? Boom, I have chase demand. So I can come up with all different plans by modifying my LP. And you'll see how that works. But now I have 4 strategies: level, chase, mixed, and a minimum cost optimal mix. So there's my minimum cost. Hey, look, 37,750, 39,500, that's pretty close. That arbitrary plan here was pretty close to the minimum plan. But that right there will minimize the total costs. In other words, if you made that 13 to 12 or 14 or 24 to 23, 25, if you change that just a little bit, that cost is going to go up. Okay. Now, the relationships, capacity and productivity. This is just a glimpse into capacity and productivity analysis. Capacity analysis, there's a whole, there's textbooks on this and you can read this. But this is what we need just for this in introductory development. Well, first of all, we have a time standard and an FTE time standard. The time standard, and this is the time standard we'll be using for everything we do in this course. 1 year is equivalent to 52 weeks in a year, is equivalent to 12 months in a year and 4 quarters in a year. And 1 week is 40 hours. That's a standard. We'll always use that in here. But then the FTE time standard, in other words, an FTE, from based on this time standard is, well, 1 FTE equals 520 hours per quarter. All that means is we're taking hours per quarter using this standard up here. For example, 40 hours a week times 52 weeks in a year gives you hours per year. Divide by 4 quarters per year gives you hours per quarter. In other words, what the FTE time standard is doing is taking this time standard and saying, well, how many hours are there in a week, in a month, in a quarter, in a year? And a year is 2080. So where is that? Okay. And so these are just standards for everything we do in this course. Well, down here, though, and by the way, you have to be careful. Some companies do not operate on a 40-hour work week. They'll have a 30-hour work week or a 50-hour work week. Okay. And some have a 100-hour work week, and then you have 2 weeks off or something like that. Some organizations do not have 52 weeks in a year. They'll have 50 weeks in a year. 2 weeks then will be vacation, 2 weeks off for vacation or sick leave. Okay, and actually the quarters. Some organizations do not have their fiscal year based on 4 quarters. An organization that you're very familiar with has their fiscal year on 3 quarters. Can you think of what it is? The university. The university is based on a 3-quarter system. The summer quarter is not part of the fiscal year. It's extra. It's over and above. And so our contracts are really for 9 months. And we work in the summer, but when we do, it's a separate contract. Okay, so this relationship holds. We have our production standard here, which is 200 items per quarter. I've already told you that. We've already used that. But I want to introduce another standard, a labor standard, which is 2.6 hours per item. Okay, now notice this is items per time. This is time per item. Well, the labor standard really focuses on the bottom-up worker efficiency. In other words, every worker requires 2.6 hours to make an item. And this is a standard. It's not necessarily an average. It's a standard that's used for planning. And that gets into capacity and productivity analysis. And I'm just going to say it's not an average. It's a standard. Now, if you have training, maybe they can do it faster. The 2.6 hours goes to 2.5 hours. If you have a design of your workspace, it becomes more efficient. The 2.5 maybe go to 2.4. If you reduce the amount of movement you make, the 2.4 go to 2.3. So this is bottom-up worker efficiency. Make sure that the worker is efficient as possible. And then the top-down planning is the actual production standard, 200 items per quarter. This is what's used top-down to determine here's how many FTEs we need. Well, the relationship between the production standard and the labor standard is simply using the time standard up here. The production standard equals the FTE time standard divided by the labor standard. Well, if the time standard is in quarters and divide that by the labor standard, then the production standard will be in quarters. And so that's how all of this works together. Okay, so even though these up here are constant, they're standard for this course, these numbers down here will change. They will change, but they're coordinated with one another. If you change 2.6, you're going to change the 200. So both of these have to work together, okay, because they're tied together through the time standards up here. And they're tied together through this equation right here. Okay. Okay, how that's used down here. Let's look at overtime production. Overtime production. So this is the last thing we'll do in this development. Okay, let's go back to the problem we started with, forecasted quarterly demand. Beginning and ending annual inventory is 3,000. The production standard is 200 items a quarter. The labor standard is 2.6. These go together. And there's our time standard again. And there's our FTE time standard. So all this stuff as we've done before. So now let's analyze overtime with chase demand. So here's our requirements in this little table here. Requirement. The first requirement is we want a chase demand aggregate strategy. That's the first requirement. Okay, we've done that, already done that. We bring down our forecasted demand here. Let me not move this around so much. Bring down our demand, and there it is. And we let our demand equal our production, and there it is. And then we divide this by 200, and there's our FTEs. So this right here, let me do this. Let me come up here and highlight this. Now this right here, boom, this satisfies the chase demand strategy. Okay, and so there it is. So boom, we started with that. 2, the maximum FTEs per quarter is 115. Okay, so now 115, we notice these two right here, both those. Well, the first quarter is less than 115, no problem. The last quarter is less than 115, no problem. These exceed 115. We don't have that many FTEs available. We have a capped workforce. And so that has to be pulled back to 115. But if we multiply that times our production standard times 200, then that's going to give us our called regular time production. And regular time, and let me highlight this. Boom. This satisfies my maximum FTE per quarter. And let's bold that. So there's the second one. Now, RT means regular time. I think I have this down here. I guess I probably should put this in here somewhere. This RT is regular time. Regular time simply means these FTEs are working regular time. And 1 FTE is 200 items per quarter. It is a 40-hour work week, 52 weeks in a year, et cetera, whatever. So that regular time is according to the standards. But when you compare the production with the demand that's required, all of a sudden we're 6,000 short. So that 6,000 then is going to be referred to as overtime production. And so overtime is allowed. In this third requirement, we need overtime. And so this is overtime. So we want 6,000 items to be produced overtime. Overtime means you work more than 40 hours a week. Okay, you've gone beyond the regular 40-hour standard time. And so this right here represents the solution to the overtime. And there it is, 6,000. Now, 6,000 plus 78,000 will yield a demand of 84,000. Because that's what we have to achieve. Okay. Now, having said that, this 6,000 extra production over time, over and above these FTEs will be working more than 40 hours a week, somewhere, somehow. Well, this can be spread any way we want throughout the year. Okay, that's not part of our requirements up here. It doesn't say where overtime has to be taken. It can be taken anywhere as long as there's no negative inventory. Well, how we spread the overtime depends on the characteristic of our strategy. Well, let's back up here and let's say, suppose we wanted stable inventory. Now, what I mean by stable inventory is simply, we want the beginning and inventory all to be equal. Let's box that in. That's what we want. So therefore, let me zero this out. What should our overtime be? Where should this 6,000 be spread in order for the 3,000 here to be stable? I say stable. In this case, it's constant, but stable. Well, we know that the beginning inventory plus production minus demand equals ending inventory. So I want our production to equal demand. But now the production is a combination of regular time and overtime. Okay, So I want the regular time and overtime, both of these, to equal my demand. So my overtime is simply going to equal my demand minus, whoops, I didn't mean to do that. My demand over here, 12,000, 12K, minus my regular time, 12K. So what's that going to equal? That's going to equal 0. Because my regular time plus overtime is going to be my production plan, and which is 12,000. Now, if I want my production plan to be 28,000, I only have 23. How many more do I need there? Well, what's 28 minus 23? That's going to be 5,000, right? So 5,000 plus 23,000 equals 28,000. That equals my demand, and my inventory is going to stay stable. Well, here at 24,000 and 23,000, it's 1,000 less than my demand, so my overtime needs to be 1,000 right there. And then finally, my demand's 20, my regular time is 20, so that's 0. So my production plan here then will be my regular time plus overtime, but if I add these two together, it's going to equal my demand. My chase demand production plan will equal my demand. So my inventory is stable. That's all that means. Okay, so now we look at our hiring and firing. The hiring and firing comes from the actual FTEs. These are the FTEs that are actually going to be used. So I have 55, 15, and 40. So notice this represents a stable inventory. So how you spread this overtime will create a characteristic within your plan. Okay, well that's nice. This is good. Let me take all out. Let's take all these things out. I'm going to go back here. There we go. So now let's have a different one. Let's say, I have all this inventory. Another strategy could be minimum inventory. You say, why do I have all this inventory? Well, let's minimize our inventory. How can we do that? Well, notice that here, remember this. I guess I shouldn't have done that. Well, this right here, boom, boom. And then the actual in this, boom. And then the overtime, boom. Okay. These right here, like we did up here, that was our chase demand. But if we want to minimize inventory, say, well, up here, I have 5,000 overtime and I have 3,000 inventory that's not even being used. I want to use my inventory. Every time I have overtime for this plan, I want to use my inventory as much as possible. Well, in the second quarter, I have 5,000 overtime, but I have 3,000 inventory. I can use 3,000 to satisfy my demand. And if I do that, that will reduce that 5,000, reduce it by 3,000 down to 2,000. And I do that right here. There it is. But then that 3,000 then is used to satisfy demand, and it goes down to 0. Boom. Now I don't have any inventory to use, so that 1,000 remains there, and the 0 carries over. Now in the fourth quarter, I have 0. I have no overtime, but I'm required to have 3,000 at the end of the year. So somewhere I have to have 3,000. I put 3,000 on my overtime. A lot of people say, why don't you put it in regular time? It's cheaper, because regular time usually is cheaper. Because if I put it in regular time, that would increase my FTEs, and then I would violate my chase demand. It's no longer chase demand. And I don't want to do that. So you put it in overtime. And then you have 3,000. So in this case, my regular time plus overtime equals this production plan. Notice this production plan minimizes my inventory when it's based on a chase demand original strategy. I started with chase demand, but notice in this case, my production plan is not the same as my demand. Why? Because I have an overtime objective. I have a minimum inventory objective with overtime. Okay? Now, this is overtime, and just briefly I'll say overtime is one way to have extra work. You can have overtime, you can have contract labor, you can have outsourced labor, you can bring in part-time labor, you can do all kinds of things. Okay, so you can outsource it, but that's more human resource management. Another thing, let's compare these two. Let's look at these two. Let's take these out. First, let's look at inventory. Up at inventory. Boom. And inventory. The first thing you notice with the inventory, quite vividly, is going to be that this is 3,000 and this is half as much. And so the minimum inventory will reduce inventory costs significantly. In this case, by 50%. And so the cost goes down. But then when you actually look at the inventory levels, this is 3,000 inventory we really don't need. That's why it's so costly. But we're coming down pretty much to zero. Now, half of the year, we're letting our inventory go all the way to zero. That's kind of risky. Omar, good question. Do the hire fire change too? No, when you change this down here, you're just changing the overtime. The hire and fire is based on these actual FTEs here. The hire and fire here doesn't change because these do not change. See, these do not change from one to the other. The only thing I'm changing is the overtime. The overtime is the only thing I'm changing. That's all. So the hire and fire is based on the FTEs. This is not more FTEs. These are the same FTEs working more than 40 hours a week. They're working overtime. So it doesn't change my capacity. My capacity doesn't change. But my productivity changes because the same capacity is working more, is producing more than the standard production standard. It's producing more than the production standard because it's working overtime. Okay, so it's costly, but also it's risky. And so people will say, oh, half of the year we're letting it go all the way to zero. That's really risky. Don't want to do that. I don't want 3,000. That's too expensive. But I don't want zero. That's too risky. I want something in between. Like what? I don't know. How much inventory do you want to carry there to guard against stock out? Sometimes that's called safety stock or reserve stock or buffer stock. I don't know. Let's say 100 items. Okay. Then if it's 100, for example, I'm going to take 100 from this overtime production and make this 2,900. I'm moving this up here to make this 2,100. And now this would be 100. This would be 100. And this would be 100. And this would be 100. I'm adding 100 up there, and it adds back in down here. Yep, let's back up. Could you please explain again why we are using overtime in Q4 and not keeping the 115 FTEs? Because the 115 in Q4 here, let's put this back. When I put this 3,000 here, then what happens is that I want my inventory to stay a minimum. So I don't want the 3,000 till the very end. Okay, so 3,000 has to be in my production somewhere. My production is either regular time or overtime. If it's regular time, then my FTEs will be more than 100. If they're more than 100, then this plan no longer is chase demand, because chase demand is defined by your FTEs, your capacity. So therefore, I put it in overtime, because the overtime, that production does not affect my regular time. And the regular time doesn't change my FTEs. So I'm keeping those FTEs the same. I don't put them back here because I want to minimize my inventory. If I put it back here, I'd have 3,000 here. And that's carrying inventory here, an extra 3,000 for an extra quarter that I don't want to do. In other words, I want to have a minimum inventory. I want the lowest inventory possible. So here, I go to the lowest and I say it's too low. Then I'm going to come back until I'm comfortable. Okay, and sometimes, like in decision analysis and psychology, it's called anchoring and then adjusting. I'm going as far as I can, and I don't like it, so I'm going to come back until I'm happy or until I'm comfortable. So that's what we're doing. I hope that makes sense. So inventory, you can look at cost, you can look at risk, and then you can look at safety stock or buffer stock or reserve stock and put it in here. And so notice there's so much you can do. And the little bit extra cost in inventory is nothing compared to the cost of stock out if you do have stock out. So to guard against that stock out, it's worth extra inventory. And that's why people do it. So far, so good. One more thing before we move on, and that is the overtime. The overtime is interesting. Let's look at this for a second. Let me shade this in, and let me shade this in. Let's compare these two. Let me point something out about overtime that a lot of companies miss. They don't really understand. There's a principle in human nature. There's a principle in human nature that when you give someone something, a benefit, and they enjoy that benefit, that enjoyment of that benefit becomes part of their lifestyle, or it becomes of their enjoyment, and they get used to it. And then if you take it away, even though you gave it, if you take it away, then all of a sudden that enjoyment went away, and it lowers the level of enjoyment back to what it was before. And studies have shown that when you have a level here, let's go this way. You have a level of enjoyment, and then you're given something and your enjoyment goes up. Then it's taken away, and the enjoyment goes back down below where it was before. You give it, it goes up. Take it away, it goes down below where it was before. And if you keep doing that, it'll just keep going down and down and down and down and down. What happens is, and there's where you get people who are disgruntled, people who do not like do not like the environment. They don't like the company. And here's another reasoning. Again, like right here, you have 0, then you have 5,000, 1,000, 0. Well, when you jump from 0 to 5,000, that's very noticeable. 5 to 1, 1 to 0, you slightly come down. If you come down slower, it's not noticed that much. But when you jump from 0 to 5,000, that's noticed a lot. So even though it's noticed a lot, and you keep doing that every year, what happens is that the satisfaction level in your employees begin to drop. It's human nature. It will happen. It drops to a level to where it is less than what a company would want as far as loyalty and commitment. So the way you satisfy that is to equalize that overtime. So this one, 213, is a lot better than 051. So this is spreading it out a little bit. This has a little bit more of a positive influence in the worker morale. This has a more of a negative influence in worker morale. And it's an aggregate but it's extremely important, and it's been documented that that is true, that it works quite a bit, that's noticeable in most companies. Now, for example, you jump up, you say, a lot of times overtime is a benefit. You're making more money, you're working more, but you're making more money. You like it, okay? And so, whoa, I like this company. You have 5,000 overtime. Oh, but then they take it away. Then you got nothing. You don't have any at all. Oh, you have 5,000. Yeah, you have 5,000 hours of overtime. You make all this extra money. Oh, but then they go to 1. Then they go to 0. So half the year you only have 0. You only have 5,000. Oh, wow, half the year you have nothing. So which has more value to a person? The 1 quarter where you have a lot, or the half the year where you don't have it at all? So what happens is people will focus on the 0 a lot more because it's contrasted with the 5,000. Human nature. So this type of profile, although it may be attractive financially, it is not attractive in a human resource morale sense. And the morale will begin to erode and decrease. Okay, because they'll say, oh yeah, when you have overtime, suppose I had suppose I spread this evenly throughout the year. Oh, that company is a great company to work for. Why? Because you can have overtime every single quarter. You have overtime, make over. Does it matter if you make 5,000 over or 1,000 all the way through? Or 6, what is 6 divided by 4? Whatever that is. 1.25. So you have a little bit over 1,000 you have overtime every single quarter. It's only 1,000. Yeah, it's only 1,000. But you still have it every single quarter. You have overtime. So that is how the conversation goes. Anyway, hopefully you see what I mean. I think you do. Now, one thing I'll ask you in the homework is if the regular time unit labor cost is $10 an hour like salaries. Okay, I picked 10 because it's easy. If the regular time here is $10 an hour, and the overtime unit labor cost is $15 an hour, time and a half, then for a labor standard of 2.6 hours, and remember, that is our labor standard, 2.6 hours per item, and each of those hours costs $10, that means that the regular time production cost, direct labor production cost, is $10 times 2.6 hours per item, $26 per item. And the overtime unit production cost then will be $39 an item. Thus, the total direct labor cost can be determined for regular time as $26 per item times the 70,000 items they're going to produce. Each one of those items costs $26 direct labor to produce. And so I call this my direct labor cost. And 39 times that would be my overtime direct labor cost. And I ask for that. I ask for these numbers in the homework. But I'll go through the homework. Now notice this is chase demand. I can do the same thing with level capacity, the same procedure, same thought process, same everything, but I'll let you do that. Okay, level overtime. This is level overtime now, and then minimum inventory. Now remember, this overtime can be spread any way you want, as long as there's no negative inventory. But it can be spread anywhere, as long as the total is what it should be and no negative inventory. So I'll leave that as an exercise. Now I have other exercises in here. So some people have asked, do you have problems we can work? Yeah, sure. Here's labor standard for 4 problems, FTE maximum, and then beginning and ending inventory. And then along with that, you're going to have your regular time labor cost, overtime labor cost, hiring cost, firing cost, and inventory carrying cost. And then for level capacity and level overtime, you'll have these values. And for chase demand stable inventory, you'll have these values. And these are just exercises where I give you the problem. Down here I give you the answers just to make sure that you know how to do them. Now, even though this is not part of the course, I take 5 minutes or so to talk about this because I think it's very valuable. This is probably much more important than you might think. Let me go through this quickly, and so bear with me because there's a lot of good information in these 4 lines here. I think they're extremely helpful and important. Let me get my files straight here. There we go. Okay, trial and error. Remember I said linear programming is one of the more popular techniques in aggregate planning, and that's true, but a lot of times trial and error is used, sometimes more than linear programming, for good reason. One is the dynamic nature of aggregate planning companies, of aggregate planning within a company. Dynamic means it changes all the time. If you have the same operation over and over again with slight changes, you can do LP. But if it's dynamic, so dynamic that you really don't have time to formulate a solution, or it changes so much that the solution is infeasible. I mean, it's not easy to do. And so trial and error, there's just throw it in trial and error, just see what we have. And so you have to be much faster dynamic. The other, it can change a lot, but also it's complicated. It's so complicated that you can't really use linear programming because things are not linear. When nonlinearity loom large, linear programming can be used. But when it can be used, linear programming is very popular for a number of reasons. One, it gives you an optimal solution. Two, the software, LP software is everywhere, and it's cheap and it's available. It's easy to use. Three, it's well known. People know how to do linear programming. And four, people understand linear programming. Sometimes it's better to have a solution that people understand that's not optimal than one that's optimal they don't understand it because they don't know how to implement it. Now, one area where linear programming breaks down is nonlinear cost functions. Where cost functions are not nonlinear, they're quadratic of some kind or nonlinear of some kind. And there's where you have linear decision rules. This is a class of optimization code, which is not linear, it's quadratic programming. You can formulate it into linear, but it's a quadratic program, or use a Lagrangian. These are a class of problems where you allow nonlinearity. The advantage of these is they're optimal. Two, they're more realistic because they will address nonlinear cost functions. But the disadvantage is they're not well known. And it needs someone expertise to know how to do them, and the software is required to know how to use the software to do nonlinear programming. Now, the best is going to be computer simulation. When done right, when formulated right, done right, interpreted right, and applied correctly, computer simulation will give you the best solution possible. Because in a complex system, when done right, it can model the aggregate planning system extremely well. But there's a danger. And there's 3 characteristics that you have to keep track of in order for computer simulation to work. Now, as I was talking about this years ago when I first came into academia, I said, this is true with aggregate planning, but it's also true with any type of quantitative analysis you're going to be using in business. And for the people who are still here, I urge you to listen to this very carefully. So this is something that you really should remember. You really should remember. Here is where companies and people make mistakes that I've noticed. One, and I'll use it with simulation, but remember this applies to simulation, to finance, to accounting, to optimization, to analytics, anything quantitative, and sometimes even qualitative. Computer simulation. Well, first of all, you have to understand the technique and apply the technique appropriately. A lot of people do not understand the technique that well. They know it just enough to be dangerous. A good example of this, and I've been in companies or organizations where this happens, it says, our competitors are using computer simulation. I want us to use computer simulation. Who wants to be in charge of computer simulation? Nobody in that room knows computer simulation, so they don't want to be chosen. Okay, I'm picking you. You're it. I don't. You're it. Do it, because I'm not hiring anyone. I'm using just the people I have, and that's exactly what happens in certain organizations. Stop and think about that. Okay, now they try to learn as much as they can, as quickly as they can. They don't understand it well enough. They put in the numbers, get numbers back. They don't work. They don't understand what they're doing. They say simulation doesn't work. Well, that's not true. Simulation will not work when it's done incorrectly. So you have to understand the technique and apply the technique correctly. And a lot of people don't. The second thing is the area of application. In other words, you have to not only understand the technique, you have to understand aggregate planning. A good example of this, it says, okay, well, I don't understand simulation. Nobody does. We can't do that. That's too dangerous. Let's hire someone who knows computer simulation. So they go out and they do a search, and they bring in a bunch of people. They hire someone, and they sit them down and say, do you know computer simulation? Oh, I know it. I'm an expert at it. I've written 10 books, and I've won awards, and I've written programs and software. I know everything there is to know about computer simulation. I'm an expert in simulation. Good. You're the person we want, I think. We want you to simulate our aggregate planning process. And the person says, okay, I have one question. And you say, what? And they say, what is aggregate planning? How can you solve something that you don't understand what it is? And how do you solve something if you don't really understand that area quite well? How can you bring in a mathematician, statistician, even a data scientist, if they don't understand the area of application, they'll solve the wrong problem? Okay, you have to have someone who knows the technique and someone who knows the area of application to solve the right problem the right way in the right manner. Okay, the right way, the solution, also the right manner that's going to be useful. The third area is the company. You have to understand the environment in which this solution is applied. And this is a true story. There was a company back east, and actually it was a linear program. They had an optimization. They solved this problem. They gave it to him, this company, and walked away. It was a nonlinear problem. It wasn't LDRs, but it was something very similar to LDRs, nonlinear solutions. They went away. They come back 6 months, and it was written up in an article. They said, how you doing? We're doing fine. Have you used the actual program we gave you? No, we never used it. Why? Well, the first time we ran it, it told us to fire these people. And we don't fire people here. We're not going to fire those people. So it told us to do something we would not do in our company. Our company just does not do that. And so we put that over here, and we went back to trial and error. You paid all that money? Well, why didn't you tell me you wouldn't do that? And I would have programmed that in. The company said something very, very profound. They said, well, at that time and even now, we cannot tell you everything we don't want. We can only tell you what we do want. And think about that. And that is profound, and that is very true. And so you can, if you think about that, I'll let you think about it. But a really simple example is that what should you do to prepare for an exam? Well, you can study, read the book, work the problems, do the study guide. On one hand, 5 things you can say, if you do those, that's a perfect preparation. That's what you should do. Now, what should you not do? That's going to jeopardize your exam. Well, you don't do those 5 things. What else? Okay, well, I don't do this. I don't get arrested. I don't rob a bank and go to jail. I don't get high. I don't get drunk. I don't get this. I don't get in a fight. I don't go to the hospital. So how many things are there? That list, I can't tell you everything not to do. You should just know that. But you don't know that unless you're you don't know the culture of a company unless you're part of the company. And so if you have a team, Make sure you have a team who understand the technique, people who understand the technique quite well, the area of application quite well, operations, and understand the company. And all three of those have to come together in order for any type of quantitative analytical solution to work. And I think that's the best advice I could give anyone working in a company. And that's why we need each other. Rarely do you have one person who knows all of that. And even if they know all of that, they're not going to be as good at all of that as multiple people at all of that. That's why we need each other. And you need a team. You need teamwork. You need to work together. So that's all I have for aggregate planning. I think it's important. I hope you guys do too. Okay, now, the other thing I want to mention, I want to cover here, is is H2, the second homework assignment. The second homework assignment is due this weekend. So in the next few minutes, I'm going to bring it up. I'm going to talk about it, how to solve it, how to go about solving it. And so let's bring up the second homework assignment. Well, actually, let's back up here. Home, linear programming, material, questions, homework questions right here. So let's open this up, download this, open this up, open. There it comes. Okay, so let's look at this real quick. And first of all, this Golden company is planning the production of 2 products in their popular line. So this is just 2 products and 3 resources. Okay, you have been designated as the analyst to respond to the request. So we have a number of requests here. First of all, Glenda, chairman of the production committee, was first interested in the optimal production mix that produces the maximum profit without exceeding capacity. And that's just solving this. Now, in case someone is rusty with this, I'm going to go ahead and open Excel. It's opening. Open Excel. And actually, I'm going to put this in here, and I'm going to go all the way. I'm not going to solve it, but I'm going to set it up. So let me take this, Control-C, copy it, open Excel up here. Here we go. And come down here a little ways, Control-V, paste it, and then paste the values, and increase this in size. So now, right here, down here, I want the values of the decision variables. So these right here is how much product X and Y I'm going to produce. And let me shade this in. The shade thing is here. Go to Arial. It's a little easier to see, as you can tell. Okay, let's format this stuff. Here we go. And format this. Okay. But then over here, I'm going to need the values. Okay, so that's going to equal my coefficients here. Whoops. Some product of these values here times these values here. Okay, whoops. Times my variables. That makes more sense. Let me F4 to freeze those. Okay, there we go. And then I'm going to copy these things down, all the way down, being. And I'll stop here. I'll go all the way down to here. Okay, so if I make one of these and one of these, then it's going to be $68. I'm using 12 resources. This is how much of each of the resources I'm using. Okay. So when I solve this thing, I go to Solver, and hopefully everyone by now knows how to do this. Okay, and then right here, my objective function is going to be that cell right there. I want to maximize my profit by changing these cells here. I'm going to add my constraint set. My constraint is going to be these values here will be less than or equal to these values here, and then say OK, and then say unconstrained variables and make sure it's LP, and then solve it. And that's how you solve this thing. I'm going to close this out because hopefully everyone will be able to do that. You don't need that. So there, whoops, see, I messed up. I'm going fast. Here's my profit value. Let me do this again. Data, solver. See, my objective function is going to be that. It's the value of my unit profit times my values. It's my profitability. And then the rest of these things are correct. Okay. Okay, we've already done this. Thank you, because I've done a lot since last week, and I don't know what you need. Let's go on to D. I agree with you, Becca. And if anyone wants to come back to this, we certainly can. Okay, and here I can put things in. Part D. The silver company, again. Did I go through environmental compliance last week? I guess I did. Assignment problem. I did do this. Did I? Yeah. Well, let's do part D. Where's D? Oh, bank assignment. Okay. Okay, let's take these. Let me take these. Let's see here. Let me take all of these. Control C. Bring in Excel again. And open a new sheet and put it in here. Okay, let's tell you what let's do. Let's expand this. Let's format this, and then bring it back, and then do this, expand this, and then format that back. Close enough. Okay, there we go. Okay, remember, okay, now this is an assignment problem. Okay, and so here's our demand over here, and down here is our capacity. Okay, and actually I don't like, let me bring these down here. Oh well. Here's our capacity. This is our demand up here. And so what we have here, let me delete this out here. We have, let me transpose this. We are used to looking at this way. Here's our capacity, here's our demand. That's how we're used to looking at it. Okay, so let's format this again. It's not going to do it. That's okay. So format this. So now down here, we're going to have these up here. Copy these down right here. And then sites 1, 2, 3, 4, 5 over here. Over here. And down here is our demand. You know, I really don't like this at all. Sorry about this. I'm going to take these here, Control C. I don't like all that stuff in there. All I want is the numbers. It's easier for me to manage. There we go. And then these over here will be these over here. There we go. So now we have personal, we have payroll, we have draft, and then we have government. Up. Yes, we do, but we have them over here. I transposed it. Okay, guys, this is real time here. And then government. Now this up here is going to be sites 1, 2, 3, 4, 5. There we go. So this is what I was trying to do. See, now over here, this is our capacity over here. And this down here is our demand. In other words, I'm taking this capacity here, and I'm shipping it to the sites. So these are going to be serviced by these sites, okay? And so so let's take this down here and get rid of this. And I cleaned it up. Took a while, but I got there. Okay, now we're going to take the same idea down here with 1, 2, 3, 4, 5 with a capacity, and this is P, D, and G with well, that's our capacity down here. Wow. This is going to be our objective here. Let's box it in. Okay, let's set this up. This is going to be the sum. This is just like a transportation model. And then bring this down. This is the sum of the columns. And this right here is the sum product of all of these times all of these. Okay, so here's my cost. And let me so this right here is going to be my decision variables. Let's shade those in. And this is going to be my objective function. Shade that in. So now, very simply, what I do, I go to Data and Solver. And now there's my objective function right there. I want to minimize my cost by changing all of these cells. That's my shipping schedule. I'm shipping these checks to these sites to be serviced. Okay? And then I'm going to add my constraints. Okay, now all of these, I want them 7, 11, 12, 13, 14. This is our capacity, so it's going to be less than that. So this is going to be like greater, this is going to be, let's just say equal to these right here, because that's what I want to service. And add these right here, this is what the different sites will carry. It has to be less than or equal to the capacity of the sites, because you can't do more than what the capacity will do. Then I say okay, nonlinear to LP, and then solve the thing, and that'll give you the solution to the first problem. Sorry about the time to get there, but I didn't have it set up. But hopefully, does everyone see how to do this? And then boom, then this will give you the answer to this one. Okay? And now the whole point of this is that this is going to be like a transportation problem, but it's an assignment problem because these checks are moving to these sites. Now I made this equal to because I want all of those to be serviced. Now it's possible that they can't all be serviced, but right now they can because I can sum. Let me close this out. Because if I sum the checks up, let me put it here, equals sum. This sum right here is this, and this sum right here, what is this? Is 1,500. Okay, so I'm servicing 1,400, but I have a 1,500 capacity, so I'll have 100 left over to here. There's going to be a slack of 100 in there somewhere. So I have 14 to service, but I have 1,500 capacity at the different sites. Okay, let's bring this back down. Good. Okay, and now let's look at the other problems. From concern about the site processing a large number of one type of check, a limit of 230 transactions per type of check for each site is being considered. What is the minimum increase in cost due to this added constraint? 230. Okay, let's bring this out of the way. We have this thing here already. In other words, we'll solve this thing and say we have cost equals, and then put it right here. So there's our cost. We're going to solve this thing and put that cost right there. But then we say I'm going to solve it again, data, solver, but this time I'm going to add another constraint where all of these must be less than or equal to 230, because some of these will be more than 230. They say 230 is going to be the limit. You can't go more than that. So each one of these cells cannot exceed 230. Say OK, and then boom, say solve. When you say solve, you get another value. That value goes here and say max 230, and then cost. Then that's that cost. And what I'm asking for, this cost, how much increase will this cost have over that cost? What's the increase? Then we want to what the increase is. Let's take the difference. Okay, then we bring this out of the way, bring this back. Then we say, well, after the transaction limit was implemented for each type of check for each site, the demand for payroll checks was increased to 900. Where's payroll? Here's payroll. The 400 jumped to 900, which increased the total demand for all the checks beyond the capacity. So you're going to have to service 900, but you don't have enough capacity down here. What is the minimum cost of processing as many checks as possible with the available capacity? Transaction limit does not apply to the dummy source. Okay, and so what you do here simply is this. Let me just copy this over. So you already have this solved. Copy this, whoops, control and copy this over. It's a copy. So what we're going to do here is say, okay, I'm going to add another row here. I'm going to add another column. And right here, I'm going to add another row here. Okay, where this is going to be a dummy. And the cost is going to be 0. Well, first of all, payroll, this jumped up to 900. Okay, so now, oh, I did it the wrong way. So now I have 1900 here, and I have 1500 here. The problem is I don't have enough capacity here to satisfy the 1900. So what I do then is I'm going to do this, add a dummy site, okay, to where this cost is going to be 0, 0, 0, 0, but this is going to be, how many? I need 400. Now I have enough capacity to satisfy this. But if I do that, let me just zero these out again. So now I'm going to go back and say, now this is a dummy. So now I'm going to sum again. Now we're going to redo it with an extra capacity here. And copy this down. And then copy this. Copy this over. Now do the sum of all of these, comma, and all of these. Okay, and again, this will be my objective function now. But now, notice what I'm saying is now I have a dummy site, but this has 400, so now I can ship all of these, but this is not going to cost anything. So at this point, I say, okay, now go to solver again. Let me reset everything so I don't get messed up. My objective function is going to be this. I'm going to minimize my cost. My decision variables are all of these now, including my dummy, and I added my constraint set. So I'm going to have all of these, and I'm just going to say equal to, because I know they're going to be equal to all of these. Add all of these are going to be equal to all of these to there. So I know, see, this is 1900, this is 1900, so the 1900, 1900, they will all be equal. But I'm also going to add the limit. And so the dummy doesn't count on the limit, only like you cannot service more than 230, that doesn't matter. But only the sites matter to the 230. Okay? And then solve this thing, and that's how you solve that one. Then you get the solution there. Let me close this out. And notice what I say here. Where'd it go? Here it is. What is the minimum cost of processing as many checks as possible with available capacity? So whatever that solution was, that's going to be the answer to that problem. It gives you your schedule here, but also gives you the cost of the schedule. So that's that question 15. Okay, so that's D. Let's come back here. Does that help? Okay, right here, can you please help on part F? More details on each frame as a minimum production requirement of 6 would be helpful. You bet. Okay, let me pull my answers up here, down here. Okay, again, let's go to a new sheet right here. Let's come down to F. Okay, and remember, I think I've mentioned this before, how you have a three sizes, small, medium, and large down here. Okay, and so you're going to have, let me put this, increase this here. And let's come down here and say, okay, we'll have small, medium, and large. Then over here, you'll have a carpentry, you'll have finishing, assembly, packaging. Okay, and so and then you'll have the minimum. You mentioned the minimum. The minimum is going to be 6. So let me just put 6 in here. Okay. Now these here have to be the production standards. In other words, the production, how many units of resources needed for each product. So, and I think I did go through this last week, where in order to do that, I said you're going to need this on this one. Each process resides 8 hours. Okay. Each process resides in a department that works on 8-hour shifts, and so your capacity then will simply be 8 hours on all of them, right? So these are in hours. Okay, now if we look at let's look at carpentry. The production standard in the carpentry is reported to complete 20 small frames in 2 hours, 32 in 4 hours, and 12 large frame in 2 hours. Let's just write that down here. Actually, let's write it over here. Carpentry, right here, will be 20 in 2 hours, 32 in 4 hours, and 12 in 2 hours. Okay, and let's just box this in so we don't get mixed up. So remember, what we need here is hours per frame, not frame per hours. So this is going to equal 2 divided by 20. The medium is going to equal 4 divided by 32 return, and the large is going to equal 2 divided by 12, right? But now that we have that set up, where's the finishing department? Is here. 24/3, 24/3, 15/3, and 24. And then you have, bring this up, and then you have the assembly department. Where's that at? The finishing is that. The assembly department is 24/3, 32/4, and 10 large 4/2. And finally, the packaging department is here, is going to be 8 in 1, 16 and 2, and 12 and 3. And then your profits down here are 8, 10, and 14. The profit P-R-O-F-I-T is going to, what did I say again? It's now lost it. 8, 10, and 14. 8, 10, and 14. Okay. And down here, these will be the values. I'll call them my mix. These are my mixes. And this is going to be the actual my decision variables. And this right here, over here would be my value. Okay. This will equal some product of these coefficients times my mix, F4 to freeze, and copy this down all the way to here. But I don't need this. I don't need this. And this is going to be my objective function. So here's my constraints right here. This is my objective function. And this is my constraints. That's a constraint. And there's my mix. So now, oh, by the way, to get these in here, you just sit here and just copy these down. Boom, 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 boom. And it'll do it for you. And then to solve this thing, data, go to solver, and the objective function is going to be this. I want to maximize my profit by changing my mixes here. I'm going to add, first I have these have to be less than or equal to the capacity of 8 hours. But then I'm also going to add that my mix here has to be less than or equal to, or let's see, greater than or equal to 6. I'll do 6 here, like that. Okay, non-negativity, simplex LP, and then solve. So let me see here. As a minimum production requirement of 6, and so that's what that constraint was. That's this constraint right here. Is 14, this constraint right here. Notice this right here is greater than or equal to 6, which is this. See? So it has to be more than that. 6 is the minimum. And they'll make more than 6 on some of them, but some will be 6. Okay? And then you solve it, and that's the answer to that. So this is just setting it, and this is going to be the type of problem you'll work on the memo. Okay, it's a good problem. It's a simple problem, but it's a good problem. Okay. Very, very good. Great. Okay. Are there any other, I'll wait here for a second. Are there any other questions on this homework assignment you'd like for me to go over? I'm happy to go over whatever you want or whatever you have. $20. Okay. Yeah, these are straightforward. Or not straightforward. These are just a 2-dimensional. I jumped to a 3-dimensional progressional silver company. Then I jumped to the environmental compliance. I think I did cover that, so everyone can see how to work that. And also this is a good one. And then the assignment problem I just worked. $13 to $18. Yes, that does. It shouldn't be E. We should have some numbers there. We definitely should have some numbers there. See, what is this? 13 through 18. Oh, what's going on here? Let's see what this is. Yeah. Oh, okay. Huh. Sorry this takes so long, but I want to get this right. Wow. Very interesting. Actually, let me make sure that I'm doing this right. Yep. Okay. Tell you what, let's do. I think actually, who said that? Who said that? Let me come back to my thing here. Okay. I need to get back to my, I got so many things open here. Whoa. 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 Wow. There they are. Yeah. And I think you may be right. Something could be off. And as a matter of fact, it's probably, you probably are right. I tell you what, I want you to learn how to do this. And I think I see what happened. And so let me go back to, if I can find, let me just minimize this stuff and bring this back. There it is. Okay. Let's just yeah, I think you're right. It could be all. Let me just solve it. Let's just work through it together and just solve this thing. And I don't want to do it fast. I want to do it slow to make sure I get it right. And if people need to leave, that's fine. But I'm going to work this thing to make it right. Okay. Control C. This is pretty much how I would do it. If this is how I would do it, instead of doing it fast, I'll do it deliberately and get it right. It bothers me when things don't work, and I think you guys are probably right. Okay, so here's our demand up here, and this is our capacity down here. Okay, and then these are our sites up here. 1, 2, 3, 4, 5. And this is the payroll. This is the personal, payroll, draft, and government. There we go. So first, let's just solve this thing real quick. So I'm going to solve this real quick, and you can see me go through it. And I appreciate those who are staying, but here, I'm just going to go ahead and solve it, because I think maybe you may be right, and let's just see who's right. And I think you're going to be right, but I want to make sure. Okay. Now then, let me make sure that the sum of this and the sum of this are going to be here. See, this is 15, that's 14. Okay, so now that I need to know. So this is going to be less than, so the capacity is greater than the demand. Okay, so now data, solve, and I want this as my objective function, minimize my cost by changing my variables here. Now my constraint set. My demand here, I want this to equal my demand. I want that to be equal. I'm going to add this right here. It has to be less than or equal to its capacity. Okay. Okay. This linear. When you solve this thing, okay, 2783. Okay, bring this over here. And 2783, you're right, it's not here. And so it is going to be none of the above. That's what I thought. So actually, you guys are going to be right that it's going to be none of the above. And the reason is because it's because these numbers here are not the same numbers. Some of these numbers are changed on my answer sheet, and I didn't see that. Everything was right except some of this demand and capacity, and that's why it's going to be slightly off, but that's going to be none of the above. 230, let's do it again. I'm going to solver, add a constraint for all of these. See, this is 400, this is 300, so we do all of this less than, whoops, what did I do? Cancel. I'm going to add, yep, all of these less than or equal to 230. Okay, and then solve it again. That's 2807.6, and that's not going to be on there either. I'm pretty sure. Oh, that's 27. Oops. This one is going to be, let's Control C this and put this right here. Value here. Let's go back here and erase this. Solve it again. This goes to here. Equals this minus this. And so the increase is going to be $24.60. And you notice here I have $24 increase cost to this. It's not even here, $24.60. That'll be none of the above. So you guys are right. It's going to be none of the above. And as we go through here, 900. What is this? The payroll checks is 900. Let's just solve this again. Payroll, payroll, payroll. This is 900. Okay. And so now I'm going to need more capacity here. So I'm going to add this. This is going to be dummy. And that's going to be 400 because now I have the 900, and that's good enough. So this has to be modified to make sure that I get all of the demand. I mean all of the row. Copy that down. And this has to go all the way to there. There we go. And this has to be modified such that all of this, comma all of this, because I'm going to have some values in there. Press return. And then I'm going to solve this thing. I don't have the 230 in there. Let me add the 230. This right here must be less than or equal to 230. Okay. Solve 3220. Whoops. Okay. Going too fast. 3220. Aha. This has to be all of these. I thought I had it, and I didn't. There we go. There I got my solution. Now I got some, they're all here. Oh. This change, this has to be equal to. There we go. Then we have the 2702. Then whatever this is saying over here. 2703, 2705, 2702. It's going to be different. None of the above. So on each of these guys, 15, just go none of the above, none of the above. It's fine with me. That makes it easy. 13, 14, 15 will be none of the above. because when I posted this, these numbers were not the same as my answers that I got for these. But hey, that's how you do it. That's how you work those problems. And there we go. Okay, so yeah, Ray Berry. Yeah, Ray, you're right. You're absolutely right. They're all close but off slightly. You're right. Because the numbers I had on my spreadsheet that I pulled the numbers off of, these numbers were these numbers here were slightly different. I think this was 6 and 4 and something like that. And so it's just going to be slightly different. And when they got put into the homework problem. Oh, really? 16 through 18? Oh, I really messed this up. Let me check to make sure that these are right too. You know, this brings up a very good point. I'm working through this. It's getting too late to continue on. This brings up a very good point that if you find none of the above in here, and everyone's getting it, go ahead and put it in there. And because I'll notice that and I'll go back and say, oh man, yeah. If there's a problem, I'll make sure that it's you know, if I don't have none of the above and the none of the above is the answer, I'll go back and change it for sure. And let me come back and look at the actual homework problem. So which one is this one? This one is 16 through 18. Okay, let's see what we got here. Yep, I have different numbers here. I really don't know where these numbers came from somehow. I think I got the wrong numbers in here. These are not the same numbers I have. Yeah, because it can't be the same. The numbers I have on my spreadsheet that I pull the answers off of are not the same as these numbers. I don't know why. I don't know how that happened. Somehow they're different. So go ahead and just put none of the above. And I'm going to be very careful on this next homework assignment to not let this happen. I don't like this. Well, the whole point of this is learning. I hope you're learning how to do this, but aggregate planning is going to be using linear programming as well. And I'll double check that to make sure that when this is transferred over, somehow it doesn't get mixed up. And I'm sorry. I apologize for this. It was certainly not intentional. And I really don't understand how this happened. I think maybe the wrong file got posted or something. I think these may have been values from an old exam. Somehow these values got kicked in there, and they are not the values I have on my answer sheet. So I work all these things out, but then somehow when they transfer, they didn't transfer right. So I think you guys can communicate with each other. If everyone's not here, I only have 8 concurrent viewers out of 30 some. Make sure you let everyone know. Work together on these or E. You're absolutely right. They're going to be E. And here's, I'm not going to let this hurt your grade, that's for sure. The whole purpose is learning, but the grade counts, the grade matters too. So I'm not going to let, when these things are misrepresented, I'm not going to let that hurt your grade. So go ahead and put E on all those and we'll count them. We'll count the E's. But these down here I think are done right. For some reason they're done right. I think, let me make sure. Now that we're talking about it, let me make sure these are done right. Okay. I have a dozen. This is going to be, what is this, 8, 10, and 14. 8, 10, 14. Yep, that's right. And I think I had these before. 8 hours is correct. 22, 32, 4, 12, and 2. Yep, that's what I got. 24, 3, 15, 3, and 24. Yep, that's what I got. 24, 3, 32.4 and 10.2. Yep. And this last one is 8.1, 16.2, and 12.3. Yep. And it's 6. Yep. So these numbers will be right. 19 and 20 will have an answer. Yay. And I showed you how to work that. That's not too bad. But the memo is going to be about this type of problem too, and I'll work through that too before you submit it and write it up, and we'll talk about what needs to be written up. Okay. Well, these are good problems to be exposed to learn about. They're practical problems. They're small, but they're practical. And whether I got the numbers right or not, just the logic behind them is really valuable. A logistic transportation problem, a bank assignment problem, and this one here is the environmental compliance problem. So all these are very practical problems. I tell you what, we've been here a long time. It's supposed to be 3 hours, no, 2.5 hours. We've been here 3 hours, and I really see that there are 9 people still here. Yep, Becca, I think you're right. Part F is right. Yep, because I got it. Yeah, I think it's going to be right. Wow, this has been very revealing, and I didn't expect this. I thought all my numbers were right, but I didn't mean to do that, but it happens. So that's probably to your benefit. So all those answers, I probably won't even grade them. I'll just give it to everyone. What was it? 16 through, I don't know what they were now. This is a lecture. Here we go. Here it is. It started with, where did it start with? Started right here. Yeah, it started with 13, 14, 15, 16, 17, 18. There's 6 problems there. Okay. But the others are going to have answers to them, as far as I know. And if it doesn't, you can tell me and I'll change it. So no problem. Well, I tell you what, we've been here a long time. Hey, I really appreciate the people who stuck with this, and we got to the final answer there. That was good. And yep, 13 through 18. So I tell you what, I'm going to sign off here. And if you have, this has been very good. I think I've found things that hopefully I don't want this to happen next time. So I'll be more careful. But anyway, it is what it is. And so between now and if you have any questions in office hours, this is Tuesday, Wednesday night, Thursday night at 7. Come and ask questions, and I'll certainly answer them as best I can. And so we did work through this stuff, and we got the answers. For everyone that stuck with me here, about 9 out of I think 16, I appreciate it. I think that was good. Hopefully you've learned, and that's pretty much all I have. I'll wait a little bit more here to see if anyone else has any questions. We have a delay here, and I think this is a good session. We got to the bottom of hopefully all the answers in the homework. And we got an introduction to aggregate planning. And then I'll work these problems here beginning next week. I'll do the quiz. And probably the quiz and homework next week. Okay. Well, great. Hey, I appreciate all of your questions. This has been a good interactive type of a session. Appreciate it. Appreciate it, guys. Okay, between now and next time I see you, a week from today, we'll have another session, and that session will just be working problems. And just like we did today, it's the application. We can talk about something, but when you apply it, you'll learn it. Okay, you'll learn it better. And so we'll be applying a lot of stuff in aggregate planning along with the other stuff too. We're going to be doing aggregate planning and the memo 2 coming up. Oh, and by then I'll have some demonstrations on memo 1. Some of them are pretty good. I'm anxious to show you what some people did. So I'll see you guys either in office hours or a week from today. So thank you. And between now and next time I see you, hey, take care.